Our fifth experiment is about the slump of freshly mixed Portland cement concrete experiment. Begin with the purpose, proceed to the apparatus needed, experimental procedures, result, and lastly the discussion and conclusion for this experiment. The purpose of the experiment is to determine the slump of freshly mixed Portland cement concrete, both in the laboratory and the field. To some extent, this test indicates how easily concrete can be placed or compact, or the workability of concrete for quality control. For this time, we will need some amount of coarse aggregate, sand, and cement for the mixture. As for the slump test, we will need a mold with top diameter of 4 inches and bottom diameter of 8 inches, scope, and a tamping rod with a length of 24 inches and rounded ends. For the sample mixing process, a shovel, an electric mixer, and a ruler to measure the slump are needed. Now we are going to look at the procedures of the experiment. First, mix concrete using arbitrary volume method, which the ratio of cement, sand, and coarse aggregate is 1 to 2 to 3, and mix them in a huge surface metal container. Pour the whole sample in the electric concrete mixer and turn the power on. While the machine is mixing the sample, add the water into the sample slowly until the concrete the desired workability and at the same time have the acceptable plasticity and cohesiveness. Once the mixing process is done, take the concrete out onto a metal form. Dampen the mold and place it with its larger base at the bottom on a flat, moist, non-absorbent, rigid surface. Hold the mold firmly in place by standing on the 2 foot pieces and immediately fill the mold in 3 layers, each approximately 1/3 of the volume of the mold. Note that 1/3 of the volume is equivalent to a depth of 67 mm, whereas 2/3 of the volume is equivalent to 155 mm. Throughout each layer 35 strokes using the tamping rod. Uniformly distribute the strokes over the cross section of each layer. Rod the second and top layers each throughout its depth, so that the stroke penetrate the underlying layer. In filling and rodding the top layer, keep the concrete above the mold before rodding is started. If the rodding operation results in subsidence of concrete below the top edge of the mold, add additional concrete to keep an excess of concrete above the top of the mold at all times. After the top layer has been rodded, strike off the surface of concrete by means of a spinning and rolling motion of tamping rod. Carefully raise up the mold without lateral or torsional motion, and the concrete is allowed to slump under its own weight. The slump test must be complete within 2.5 minutes after taking the sample. For the last step, measure the slump by determining the vertical difference between the top of the mold and the displaced original center of the top of the specimen. This can be measured using the upturned cone and slump rod as a guide. If 2 consecutive tests on a sample of concrete show a falling away or a shearing off of a portion of concrete from the mass of the specimen, the concrete probably lacks the necessary plasticity and cohesiveness for the slump test to be applicable, and the test result will not be valid. Now, let's see the outcome of the experiment. After doing the experiment, we found out that the slump for our concrete sample is 29 mm and our type of slump is true slump. Now, let's discuss about our result. In conclusion, the concrete slump test measures the consistency of concrete before it hardens. It is conducted to check the workability and plasticity of freshly mixed concrete. The slump that was obtained in this experiment was true slump, means that the slump have general drop of the concrete mass evenly all around without disintegration. True slump shows that this mixed concrete has high stiff consistency. In a true slump, the concrete just subsides shortly and more or less maintain the mold shape. This type of slump is the most desirable. Since the slump is between 29 mm, this concrete sample can be said to have low workability. This kind of concrete is good to be used for foundations with light reinforcement, and a hand-operated machine is used to vibrate the concrete. That's the end of our video. Thanks for watching.